An Introduction to Balancing Equations by KayScience.com. Chemical equations always have reactants on the left and products on the right, separated by an arrow in the middle. In this example, we have these reactants, where for a reaction to take place, the bonds must break. When the bonds break, we now have the individual atoms, which must collide with enough energy. For new products to form, the atoms become rearranged to form these new products as shown here. It's question time. Attempt these questions to check your understanding. The law of conservation of mass states the total mass of products formed in a reaction is equal to the total mass of reactants. For example, if A reacts with B, forming C, and there's 5 kilograms of A and 2 kilograms of B, the law of conservation of mass states there will be 7 kilograms of C. Pause the video to calculate what is the mass of reactant B. The answers will follow. Pause the video now to check your answer and make any corrections to your mistakes. This same rule is applied to balanced symbol equations. It's question time. Attempt these questions to check your understanding. In this word equation, hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. Here is the symbol equation, and the question is it balanced? To figure out if a symbol equation is balanced or not, I'm going to teach you the following technique. Underneath the reactants and products, we then write the elements involved in the chemical reaction, making sure they're on the same row. For a symbol equation to be balanced, it must have the same atoms on both sides, and there must be the same number of atoms on both sides as well. We're now going to count the number of atoms to check if this equation is balanced. The equation shows us how there is one hydrogen atom in the HCl and one hydrogen atom in the NaOH. Therefore, in total, there are 2 hydrogen atoms on the left. On the right, we can see there are 2 hydrogen atoms in the water molecule. Therefore, we write 2 next to the H. In the HCl, we can see there is 1 chlorine atom, so we write 1 next to the Cl. And in the NaCl, there is 1 chlorine atom as well, so we write 1 next to the Cl. In the sodium hydroxide, there is 1 sodium atom, so we write 1 next to the Na. And in the sodium chloride, there is 1 sodium atom, so we write 1 next to the Na as well. In the NaOH, there is 1 oxygen atom, so we write 1 next to the O. And in the H2O, there is 1 oxygen atom, so we write 1 next to the O on the right. Using this technique, we can see how we have the same type of atoms on each side, and we have the same number of each atom as well. So we know this equation is balanced. It's question time. Attempt these questions to check your understanding. Pause the video now to check if this equation is balanced. The answers will follow. Using this technique, we can see this symbol equation is balanced because the number of each atom is the same on the reactants and the products. Pause the video now to check if this equation is balanced. The answers will follow. Using this technique, we can see the symbol equation is not balanced because there are 3 oxygen atoms on the right and 2 oxygen atoms on the left. So we need to balance this equation. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.